Okay, so in this video I'm going to have a look at another type of transformation called enlargements. In a previous video I did transformations, and we looked at 4 types of transformations, and they were translation, central symmetry, axial symmetry, and rotation. So here we're just going to have a look at another type, a 5th type, called enlargements. So an enlargement is just simply a transformation in which the size and the position of the object changes. So in order to find, in order to carry out an enlargement, you need 2 things. You need the center of enlargement, and secondly you need the scale factor. And we usually call the scale factor K. So let's have a look at an example of an enlargement. So let's take, and I'm going to do this freehand, but let's take a triangle, and what we're going to do is enlarge it by a scale factor of 2. So let's call this A, B, C, and remember our K here is just 2. Let's take our scale factor, or what you call the center of enlargement rather, as O here. So what you do, all you've got to do here really is start at O here and draw a line through each of the 3 vertices in this case. So we're just going to draw a line up through here. I'm going to draw another line up through here. Doesn't matter how far you go. And up through here. And that's it. So what you do next is you just measure the distance here. Measure the distance between O and A. So let's say it's, I don't know, 1 centimeter, for example. What you do is you get your compass and you measure 2 centimeters on a ruler using your compass, and you just simply draw an arc there that's 2 centimeters. So that would be 2 centimeters distance there from O. You then measure C here, or 0 to C, measure that with a ruler, and again using your compass double the distance here, and the same here. Take a ruler, measure the distance from O to B, and using your compass measure double the distance on a ruler, draw an arc here, and there are your 3 points. So you just connect up these 3 points here. So we're just going to connect that to that, that to that, and that to that there. So in this particular case, this was A, so this point here is going to be called A dash to show that it's an image. This point here was B, so this point up here is going to be B dash. This is C, so this is going to be C dash here. Now, what you'll find here is that the lengths will be doubled as well. The lengths will be increased by whatever the scale factor is, in this case 2. So for example, what we've seen here, the distance from here to here was 1. Let's say, I'll put in some measurements here. Let's put in 3 measurements. Let's say this was 1 centimeter here, this was 1.2 centimeters, and this was 2.1 centimeters here. Well, what you'll find is that the equivalent lengths up here will be doubled. So this here will be 2 centimeters, this side here will be 2.4 centimeters, and this side here will be 4.2 centimeters. Now, if you actually didn't have the scale factor, but you just had the 2 triangles here, and you knew that this was the image and this was the object, you could just simply work backwards, and you could find that K, your scale factor, is in fact any image length divided by the corresponding object length. Now, this is an important formula in this particular topic. So you can see you have 3 things in this formula. You've got K, you've got one length which is an image length, you've got another length which is an object length. So if you have any 2 of these, you can find a third one. So in this particular case, say we had 2.4 and 1.2, we would just say K is equal to 2.4, which is our an image length, B dash, C dash, divided by its corresponding length in the object, which is the length BC, which in this case is 1.2. So when we divide 2.4 by 1.2, we get 2, which is our k value. Now, let's just do another example. Let's take a rectangle here. Okay, so let's take this rectangle here. Let's call it A, B, C, and D. Now in this particular case, let's take the center of enlargement here as being D. So the center of enlargement can be part of the object itself. So all you've got to do is, let's take K here again as being 2. So we're going to double the size, the lengths of each of these sides of this rectangle. So again, you do exactly the same thing again. You start at the center of enlargement and you draw a line through each of the vertices. So we're going to do this kind of thing here. You get your compass and ruler, you measure the length from D to A and double it. You measure your length from O to, or D to B here and double it, and D to C here and double that, and draw an arc there as well. And you just simply connect up these 3 points here. Well, 4 points really. What you'll find here is this D here will remain where it is, so that's actually D dash. So okay, I'm a little bit off there, but you get the idea. So this is our image, this green rectangle here. So this was A here, this will be A dash, this is B here, this will be B dash, this is C here, this will be C dash. Okay, so that's that one. Let's move on to the next one. Now let's take another rectangle here. So let's take this rectangle here. And again, let's call it A, B, C, and D. Now let's take our center of enlargement again here as being D. And this time let's take K as being a number less than 1. So let's say a half. So K is less than 1 in this case. What do? Well, you do exactly the same thing again. You take your center of enlargement, draw some lines through each of the vertices here. And you do exactly the same thing again. Well, D is going to remain where it is, so that's just going to be D dash. Measure the distance between D and A and half it. Draw an arc here. Measure the distance between D and B, half that, so you're going to end up drawing an arc here. Same with D and C, half that distance, and you end up with 4 points here. Connect those up, so your image is actually inside the original object. So this was A here, so this here will be A dash. This is B here, so this will be B dash. This is C here, this will be C dash here. Okay, let's look at another example. This time all we want to do is find a center of enlargement. So we're going to find a center of enlargement now. So let's say we have two triangles. Let's take this one and let's take its image. Let's say it looks like that. Not quite right, but you get the idea. You want to find the center of enlargement here. So what you do is, let's say this is A, B, C. So this is going to be A dash, B dash, and C dash here. So all you've got to do is start at the image, draw lines through the object. Now we only need two really, so I'm just going to take this one as well. I'm going to take C and draw it through C. And what I end up with is a point of intersection of those two lines here. This will be my center of enlargement down here. So that's all you've got to do there. Now again, if you happen to have two of the sides, let's say this was 8 and this was 4, you didn't know the scale factor, you know that K is an image length divided by an object length. So in this particular case it would just be 8 over its corresponding side, which is 4, so our scale factor here would be 2. Okay, now we've looked at lengths and enlargements, what enlargements do to lengths. So let's have a look at areas then. So what we'll find is that k squared will be equal to the image area divided by the object area. So this is the second formula that's very important in this topic here. Again, you have three things in this equation. You've got k, you've got an image area and an object area. So if you have any two of these, you can find a third one. So let's have a look at an example of how we might use this. Let's take a triangle. So this triangle here, and we have another little triangle inside it, and let's say we got A, B, C, D, and E. And let's take some lengths here. Let's take this as being 4 centimeters, and let's take this as being 14 centimeters. Okay, so let's just answer some questions here. Now, we're just given another bit of information here. We're told that the triangle ADE is the image. ADE is the image of the triangle BCE. With center of enlargement E. So this here is our center of enlargement down here at E. This small triangle here, ADE, is the image of this large triangle here. So our k is going to be less than 1. K is going to be less than 1. So let's have a look at some questions that we can do around this particular triangle. Okay, so the first one, question number 1 then. Let's have a look. Question number 1. So question number 1 is just simply to find the value of k. So in other words, find the scale factor. Find the scale factor. So we know we have two formulae in this particular topic, and the first one is k is equal to any image length divided by the corresponding object length. Now in this particular case, the only lengths we're given are down here. So we can see that an image length here is 4. So this is our image. The small triangle is our image. So 4 can go on the top. Its corresponding object length is from E to C here, the large triangle, the base of the large triangle here, and that's actually 18. So that'll just give us our scale factor of 2/9. And we kind of guessed that it was going to be less than 1 anyway, because the image is a lot smaller than the object. So our scale factor k is 2/9. Okay, so let's have a look at another question around this triangle, or these triangles here. So let's see if we can find a ratio. The ratio of the length EA to the length EB. So EA to EB, so that's going to be, let's see, that's going to be EA to EB. Now what you'll find here is, because we have triangles here, what we've actually got are similar triangles. In other words, that if we take, for example, this angle here is common to both triangles, so it's the same in both triangles. This angle here is going to be the same as this angle here, and this angle here is going to be the same size as this angle here. So we've got similar triangles. So enlargements will give you similar shapes where the angles are preserved. The angles remain the same. So we know from what we've done previously that in previous videos that triangles that are similar have sides that are in proportion. So we have similar triangles here. We're looking for the ratio of EA to EB. So that's going to be exactly the same as this length here, ED to EC. So we can write that down. So ED is 4 and EC is 18. So that's our ratio there. So that's just 2 is to 9. 2 is to 9. So that's our ratio of sides. Okay, let's have a look at let's have a look at areas then. Let's have a look at another ratio. This time the ratio of the area of the triangle ADE to the area of the triangle BCE. Okay, so ADE is this triangle here, the small one, so that would be our image our image area to BCE, which is our object area. So this is our image area to our object area. Now we know that from our second formula that k squared is just that ratio. It's the image area divided by the object area. We know that k, so the ratio of our image area to our object area is just k squared. So our k is 2 over 9, so all we've got to do is square that, and that will give us 4 over 81. So our answer here is actually 4 is to 81. 4 is to 81. Okay, so let's have a look at one last question then before we finish, and it's number 4 here. We're going to try and find the area of the quadrilateral ABCD. Find the area of the quadrilateral ABCD. So we're really looking at this area in here. Now we need an extra bit of information here. Do we have that? We do. So find the area of that quadrilateral given that the area of triangle, now it's the object one, so we're going to look at BCE. So it's the triangle BCE. That's our object area is 202.5 centimeters squared. So we want to find the area of that quadrilateral ABCD given that the area BCE, so remember BCE is the object area, and we want to find the area of this quadrilateral here. So what I'm going to do first of all is find the image area. I'm going to subtract it from the object area, and that will give me the area of this quadrilateral here. So how are we going to find the area of this image here? So all we've got to do is use our second formula here. We can see that k squared is equal to the image area divided by the object area. So we know that k squared is 2 over 9 squared. That's going to be equal to the image area, which I'm looking for in this case, so I need to find the image area, divided by the object area, which I know is 202.5. I was given that in the question. So that would give me 4 over 81 is equal to the image area divided by 202.5. Now, if I just continue on then, all I've got to do is take 4 over 81, multiply it by 202.5, and that will give me my image area. And what you'll find then is that the image area is just 10 centimeters squared. 10 centimeters squared. Now we want to find the area of the object, isn't it? Oh no, sorry, yeah, we want to find the area of the quadrilateral, I should say. We want to find the area of the quadrilateral. So we have the object area, we have the image area, so all we've got to do is subtract them, and that will give us the area of this quadrilateral here. So what we're going to do is to find the area of A, B, C, D is equal to 202.5, which is the area of our object, subtract 10, and that will give us 192.5 centimeters squared. And that's it. That's all I'm going to do on enlargements.